Ever wanted to try a magnetic loop antenna? Let me show you how I built mine for 6 meters in less than an hour. Stick around. For this build, you will need a 12mm copper pipe. Mine is PVC clad. Yours can be either bare copper or PVC clad. It doesn't really matter. I needed about 155 centimeters of it. You will need a 40mm PVC pipe, about 1 meter of RG213 and 5 meters of RG58. I've used a 140-43 toroid for mine, but it's probably a better idea to use a 140-61 toroid. Also, I've included in the bill of materials a BNC connector for the end of the feed line. The tools I used for this build is a soldering iron, a hand drill, a 5mm and a step drill bit, a sharp knife, pipe cutters, coax and side cutters, and calipers and tape measure. You start by cutting the copper pipe to a length of 155 centimeters, and you make a mark at 10 centimeters from each end. Then you try your best to bend this into a perfect circle so that the marks meet up at the one end of the circle. The more perfect you make this circle, the easier this is going to be later on when you need to fasten the antenna to the PVC pipe. So try your best to make it as round as possible. When you are satisfied that the loop is as round as you are able to make it, you cut off both ends at the 10 centimeter mark. After that, you want to thoroughly deburr the inside of the cut and flatten out the loop so that it's in a plane. It's no longer a three-dimensional object, it's now a two-dimensional object, so to speak. One optional step that you can make is use some acetone to wipe off any markings on the PVC pipe or on the copper pipe, so that it's all nice and white and clean. That will definitely increase the wife acceptance factor when you later on go to plant this in your garden. Next, you need to drill a pilot hole in the top of the PVC pipe. You'd want to do that about 20mm or half the diameter of the PVC pipe down from the top. Make sure you drill it at a right angle and going straight through the center of the pipe. Next up, you use the step drill bit to widen out the holes to fit the copper loop. Try and make sure it's a snug fit. It's not too loose in there. That's just going to make the loop flap around when you mount it. You can use one of the 10 centimeter cutoffs to test fit the hole. After that, it's time to install the loop in the newly created holes and move it halfway around so that the open end meets at the lower part of the PVC supporting pipes. And most important, do remember to stay hydrated when you work on antennas. Really, really important. Make a mark at exactly the same center point where the ends of the copper loops meet. And use a rubber band to create a straight line at that mark around the supporting pipe. Then you use a ruler to mark off exactly 1/4 of the circumference of the supporting pipe to either side of the mark that you made. Use the pilot drill and the step drill to drill similar holes there. This is going to be the lower fastening point of the loop. For the coupling transformer, you will need to remove about 20 centimeters of jacket and shield from the RG58 cable. You pass that through the center of the toroid 3 times and fit to length. Then you solder the center to the shield as shown on screen. Now, to install the toroid inside the PVC pipe, you thread a piece of string down from the top of the supporting pipe through the toroid and back up the supporting pipe. Then you carefully pull the string to move the toroid into position, and then you're probably going to need some tools to align it with the hole so that you can actually thread the loop through it. You continue by rotating the loop carefully and with rather small steps so that the opening in the loop is right on the one side of the top of the supporting masts. If you use small careful movements, it's not going to bind up too badly. For the capacitor, you need to start by removing the jacket and shield from the 1 meter length of RG213. Make sure that both ends of that cable has really clean cuts. That's important not to have arcing in the capacitor. Once you have that freed up, you can thread the center of the RG213 inside the loop and then about 10 centimeters back into the other side of the loop. This is what we're going to use to tune the loop once we get it mounted. So you need to mount the loop in a suitable location, preferably at least a few meters away from anything iron or conductive. And you will tune the loop by moving the RG213 core in and out of the loop. You will get the lowest resonant frequency when the core is centered around the opening of the loop. So just move it back and forth, connected to an SWR meter, and you will find a perfect match for the frequency of interest. One future improvement I will probably want to try out is a much shorter RG213 core. That's in all probability going to improve efficiency, and it's also going to make it a lot easier to tune. So, does it work? Absolutely. I've had less than stellar conditions on 6 meters for the last 24 hours, but I've been spotted at 98 locations, as far away as Italy Tango 9, Italy Papa Quebec, which is 2,363 kilometers away, which I think is very alright for 60 meters. Also, I've had 22 contacts on FT8 running with 25 watts from the IC7100. The antenna is mounted about 2 millimeters above ground level in a highly built up area, so not a really ideal placement for an antenna. And also I think about 25 watts is about the limit of what that toroid can handle before it gets hot. If you want to create an antenna like this and handle more than 25 watts, you will probably need to use a bigger toroid. And yeah, if you made it this far, I would like to say thank you so much for watching. If you're interested in this antenna or similar antennas or other projects, I would encourage you to subscribe for future updates. If you have comments or questions, you can comment, or just because you can like. So until next time, 7-3.